Alright, in this video we're going to look at solving exponential equations, and the problems that we're going to do in this video, we're not going to be able to get the bases the same. Remember, whenever you're solving an exponential equation, you want to always try to get the bases the same, and I have another video on that where we get the bases the same, but you can see here we can't. In other words, the 3, we cannot write that as 2 raised to a power, or the 2, we can't write that as 3 raised to a power. So how do we solve these equations when we can't get the bases the same? Well, you just take the natural log of both sides. And yes, if you wanted to, you could take the log of both sides. Okay? Usually I either take the natural log or the log. Okay? So in this one, we'll go ahead and we'll just take the natural log of both sides. That's ln. So the natural log of 2 to the x equals the natural log of 3. Alright, so now if you remember the property from logarithms, this exponent here, we can take this exponent and move it down in front and multiply it. So that's x times the natural log of 2 equals the natural log of 3. And now we just need to get the x by itself, so I'll divide both sides by natural log 2, and that gives me x equals the natural log of 3 over the natural log of 2. Now, some teachers may accept this form. If not, you just have to punch this into your calculator, and when you punch it into your calculator, you end up with 1.585. Okay. Alright, so let's look at another one. Alright, so same thing here. We can't get the bases the same, so I'll take the natural log of both sides. Alright, and then we'll use the property again that says we can take the exponents and bring them down in front and multiply. So x plus 2 times natural log 3 equals x times natural log 5. Now to solve this, well, all we have to do here is clear the parentheses. It's just like solving an equation now. So I'll distribute the natural log 3. So I get x natural log 3 plus 2 natural log 3 equals x natural log 5. Alright, so now to solve this, everything that has an x in it has to come to one side, and everything that doesn't have an x has to go to the other side. We got to get x by itself. So what I'm going to do is subtract x natural log 5 to both sides, and then that'll get my x terms over here, but then for this term I'm going to subtract 2 natural log 3 to both sides because it doesn't have an x, so I'm going to move it to the other side by itself. And so you can see here, these cancel out, these cancel out, so I'm left with x natural log 3 minus x natural log 5 equals, and then I'm left with negative 2 natural log 3. Alright, now to solve for x, you see how I have a common factor here of x, this x and this x? Well, I can factor it out. It's like factoring out the greatest common factor. So x times natural log 3 minus natural log 5 equals negative 2 natural log 3. And then to get the x by itself, I'll divide both sides by natural log 3 minus natural log 5. Natural log 3 minus natural log 5. So this gives me x equals, see these cancel out, negative 2 natural log 3 over natural log 3 minus natural log 5. And when you put this into your calculator, you should end up with 4.3013. That's rounded to 4 decimal places. All right, so let's look at another one. All right, so same thing. We cannot get the basis the same. So I'm going to take the natural log of both sides. So natural log 7 to the 2x plus 3 equals natural log 5 to the x minus 1. And then we use the property again that says we can bring the exponents down in front and multiply. So that's 2x plus 3 times natural log 7 equals x minus 1 times natural log 5. And then I'm going to clear the parentheses, just like we did in the previous problem. I'm going to distribute natural log 7, and here I'm going to distribute natural log 5. So I get 2x natural log 7 plus 3 natural log 7 equals x natural log 5 minus natural log 5. Now, solving for x. Everything that has an x has to come to one side. Everything that doesn't have an x has to go to the other side. So I'm going to take this term and move it over here, and this term and move it over here. So I'm going to subtract x natural log 5 to both sides. And then here I'm going to subtract 3 natural log 7 to both sides. And we can see those cancel out and those cancel out. So I'm left with 2x natural log 7 minus x natural log 5 equals negative natural log 5 minus 3 natural log 7. Alright, and so here we have a common factor of x. We can factor that out, factoring out the greatest common factor. And so that's x times 2 natural log 7 minus natural log 5 equals negative natural log 5 minus 3 natural log 7. Alright, so then to get x by itself, I'll divide both sides by 2 natural log 7 minus natural log 5. So 2 natural log 7 minus natural log 5. And we can see those cancel. So I'm left with x equals negative natural log 5 minus 3 natural log 7 over 2 natural log 7 minus natural log 5. And put that into your calculator. That gives us negative 3.2629. Alright, so we've got two more. Alright, so let's take a look at this one. I can't get the basis the same, so I'm going to take the natural log of both sides. So natural log e to the x plus 1 equals natural log 8. Alright, so now over here on the left hand side, well, that's just x plus 1 equals natural log 8. So let me go over how I got the x plus 1. If you remember, there's a property that says the log of base b of b to the x is equal to x. See, if the base of the log and the base here, if those are the same, your answer is your exponent. Okay? Now remember, the natural log of e to the x plus 1 is the same thing as log e to the x plus 1 with base e. Remember, natural log means log base e. And then since those are the same, your answer is your exponent. So that's where that comes from. So now I just got to get x by itself. So I'll subtract 1. So x is equal to -1 plus natural log 8. And so here I get x equals, and then you punch that into your calculator, that gives you 1.0794. Alright, so this is the last one. Alright, so let's take a look at this one. Alright, here you see how we have this term here, the 3 raised to a power. Well, we have to isolate that. We have to get it by itself. So I'm going to need to subtract 7 to both sides, and that gives me 2 times 3 to the x minus 1 equals 3. And then I'll divide both sides by 2, and that's going to give me 3 to the x minus 1 equals 3 halves. Now I can take the natural log of both sides. So I get natural log 3 to the x minus 1 equals natural log 3 halves. And then I'll use the property that says I can bring this in front and multiply. So that's x minus 1 times natural log 3 equals natural log 3 halves. And just like on all the other problems, I'm going to distribute the natural log of 3. And so that gives me x, let me change the colors back, that gives me x natural log 3 minus natural log 3 equals natural log 3 halves. Okay. And so now I'll add natural log 3 to both sides, because I have to isolate the term with the x in it, so this has to come over. And so x natural log 3 equals natural log 3 halves plus natural log 3. And then to get the x by itself, I'll divide both sides by natural log 3. And so that's x equals natural log 3 halves plus natural log 3 over natural log 3. And if we punch this into our calculator, we end up with 1.3691. Alright, so hopefully this video helped. I tried to cover everything you would come across. So hope you liked it. Don't forget to like and subscribe. Alright, thanks.